now we're going to have ways of finding all the cube roots or all the fourth roots or all the fifth roots of numbers. Not just 8 and 16, but any number that we want. Okay? They could be complex numbers, they could be real numbers, they could be a combination of real and imaginary. And the best way to kind of go about showing you how it works is to just get right into it. I'm going to break it up step by step. And if you follow those same steps, no matter what kind of problem you have, then you're good to go. Okay? So for example, if we wanted to find the 3 cube roots of, let's say, 8i. Okay, so first, whatever number they give you, we're going to write it in CIS form because it's going to help us tremendously if we can convert it to CIS form. Okay? Now, for CIS form, we need a radius and an angle. Those are the two things that we needed. Okay? We have formulas to find the radius and the angle. However, if you know where 8i is when you graph it, we know that it's up here. And just from looking at it, or by inspection, we would say, how long is the radius? From 0 to this point is 8 units. And what angle gets us to this, which is, we'll say pi over 2 then, and 8. Okay? So now, in CIS form, we'd say that 8i is the same as 8 CIS pi over 2. Cosine plus I sine theta. So this is the same as 8 times cosine of pi over 2 plus I times sine of, yeah. It's just a different way of writing it so that we don't have to write all that out. Okay. Now, second thing, we're going to use the equation. In this case, it's going to be, if I'm looking for cube roots, it'll be x to the what power? Third equals, and then whatever the number is that I'm finding the cube roots of goes over here. If we were finding the fourth roots, we would do x to the 4 equals whatever the number is. In this case, it's just x cubed equals 8i. Okay? And then what we're going to do is let my answer, so the x is what I'm looking for ultimately. There are going to be 3 x's that I can cube that will give me 8i. And in fact, if you have your calculators out, I'm going to ask you to verify this in a minute so you can see that it works and it's not just a magic trick. Okay? But to start, we're going to let r equal any number in trig form. Okay? So this is our starting point. And then now what we do is plug into the equation and use Demoivre's theorem. So what that looks like now, you're going to take r CIS theta, you're going to plug it into x, and those of you that were here Friday, what do I do with the radius when it's cubed? So it's r cubed. And now what happens to the angle when I cube it? Good. So we multiply it by 3. So when I plug r CIS theta into x cubed, Demoivre's theorem tells us that it's going to become r cubed CIS 3 theta. And now 8i, I have 8i written in trig form right here. So I'm just going to write it as 8 CIS theta. Oh, sorry, I know what theta is. That's my bad. Theta is pi over 2. Okay, and now we're in pretty good shape because we basically have to match everything. This r cubed has to equal what? Has to equal 8. So right away, that tells us that the radius is going to be 2 if I cube root the r. And now, this is the part that's a little tricky, but this angle over here is pi over 2, right? What could I add to pi over 2 so that I end up going right back to the same spot? You guys remember adding that 2 pi k from a while back, right? That was ages ago. So what we're going to do is say this. R is going to equal 2. And now, let me change colors again. This 3 theta has to match up with this angle, pi over 2. Or really, any angle that ends up landing in the same spot. Okay? So that was the hard part right there. So let's recap what we've done so far. Take whatever number they give you, write it in CIS form so that we have an idea of what the radius and the angle is for that number. Then you just plug in RCIS theta, you plug it into x, you do whatever power it says to do, write it out. So now we have r cubed CIS 3 theta, and then we compare this trig number to the trig number that corresponds to the number they gave you. Does that make sense? So that now we can figure out what r is, because r cubed's got to be 8, so r is 2. And then this 3 theta has to be pi over 2, or any other angle that is in the same spot. Okay? So here's how we find all our answers now. We want to figure out theta, or what thetas to use. So we're going to divide this by 3. And now we get pi over 6 plus 2 pi over 3 times k. And again, k is any integer here, but we're going to pick some convenient values now in just a second. Okay, so once we know what the radius is, and once we know what the angle is, or what the angles are, rather, now we can go to the last step, which is to find the answers using k values. And I'm going to say to just always start with 0, 0, 1, and 2. I'm using 0 because that's the easiest, and you have to go consecutively. You don't want to just bounce around and pick 0, let's say 0, 3, and 6, for instance, because if you pick 0, 3, and 6, you're going to get the same answer 3 times. We don't want the same answer 3 times. We want 3 different answers. Okay? So no matter where you start, you're just going to go in order. And of course, 0 is the easiest place to start. So if we had, let's say, 4 answers that we were looking for, I would use 0, 1, 2, and 3. Does that make sense? And the most we'd ever do is maybe have 5, like 5 fifth roots. So then I would just do 0, 1, 2, 3, and 4 until I have all 5 answers. Okay? So now here's what that looks like. When k equals 0, my radius is 2. That doesn't change. Okay? But now I'm going to use my theta equation. Exactly. If I plug 0 in for k, this goes away and it's just pi over 6. So x would become 2 CIS pi over 6. And then now I can just figure it out. Okay? 2 CIS pi over 6 is really 2 cosine of pi over 6 plus I times sine of pi over 6. Cosine of pi over 6 is it is root 3 over 2. Sine of pi over 6, 1/2. So when I'm all done, my first x value We could even call it x1 if you want, because we're going to have three of them. Root 3 plus I. So what this means then, whoa, that was, should probably look at the page when I'm circling. Okay. What this means is that if you take this and plug it all the way back in to this equation right here, if you cube this x value, what should I get? Just 8? What does it say right here? 8i. Okay? Take your calculators just so you can see it, because this is a good way for you to check to make sure that you're getting these answers correct. Take root 3 plus I. Yep. Cube the whole thing, and your calculator should say that's 8i. If you don't know where the I is, oh, it's the decimal point when you go to second, right? So if I do it, second, root 3 plus I cubed, sure enough, 8i. Okay, so there's one out of the three answers. Okay? Now what do? I use 1 for k. So now when k is 1, r is still 2, that never changes. But now what's theta going to be? Let's see, let's go back to my theta equation. Theta was pi over 6 plus 2 pi over 3 times whatever k was. Everybody agree? So we're doing pi over 6 plus, if k is 1, then I'm going to add 2 pi over 3, right? Which is the same as 4 pi over 6 if you get a common denominator. So there's where we get 5 pi over 6 from. Into k in the theta equation. Yeah. So we're just going in order, starting with 0 because 0 is easy, until I have my three different answers. Okay. So now if I go ahead and figure this out, then x2 will be, again, 2 CIS, and now I just use my new angle, 5 pi over 6. So that's 2 times cosine 5 pi over 6 plus I times sine 5 pi over 6. What's the cosine of 5 pi over 6? Negative root 3 over 2, I. And then sine of 5 pi over 6, still a half. So my second cube root of 8i is negative root 3 plus I. So this is my second cube root. And again, you should always check. Sure enough, okay, that one checks out. And we got one more to go. So now I'll do when k is 2. When k is 2, what's r? And what's theta? Yes. If you don't know, look at your theta equation. Back up here. I didn't plug in 2. I plugged in 1 for the last one. I plugged in 0, and then 1, and I'm going to stop with 2 because that'll give me my three different answers. Yep. Exactly. And if it were to the fourth, you'd have 4 of these. Do we have it yet? What is it? It's 3 pi over 2. Let's verify. I'm just going to, because it's going on YouTube, let's not skip it. Pi over 6 plus k. If k is 2, then what's this really? 4 pi over 3. And double everything to get a common denominator. That's 8 pi over 6. So 9 pi. Yep, 3 pi over 2 is our angle. So then x3 will be what? 2 CIS 3 pi over 2, which is 2 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. The cosine of 3 pi over 2 is 0. I And the sine of 3 pi over 2, negative 1. So negative 2i is my final cube root. And let's check it out. Negative 2i cubed. Whoops. There it is. Okay, so that's how we find roots of any number. Okay, now I picked a very nice example. What I mean by that is that all the angles that we worked with worked out wonderfully on the unit circle, right? If, for whatever reason, the angles that you get do not work out wonderfully, then you might be leaving your answers in CIS form. Like your answers might be 2 CIS 3 pi over 7, 2 CIS 8 pi over 7, or whatever the case is, and you can leave it that way. Or, again, if they want you to give approximations, then you can just use the cosine and sine buttons on your calculator to get an approximation for what those values are. Okay? Question?
How do you know AI is an anti-coordinate?
Good question. So how do I know 8i is over here? Because when we graph complex numbers, we graph the real on the x-axis, so your a coefficient goes on x, and then your b value goes on y. Right. Yeah. That's part of what you missed on Friday, yeah. Now, so this is a nice example because we just knew by looking at it what the radius and angle were. If for some reason, and I'm not going to do the whole thing, but just so you guys can get an idea of how to start. If we wanted to, let's say, find the 4/4 roots of, I don't know, three plus root 3i, let's say. Okay. We would have to, again, put in CIS form. And to do that, we need R and we need theta. For those of you that were here Friday, how do we find R if I have this number here? A squared plus B squared.
Yeah.
So if I square the A, square the B, what is that? 9 plus 3 is 12. So I get that the radius here is 2 root 3. So everything we just did earlier gets replaced with 2 root 3. Okay, that's the only difference so far. And now theta, we could do tangent of theta equals B over A, root 3 over 3. So that would be pi over 6. We're just using the formulas from Friday, Jenna. Yeah, tangent's B over A. Cosine was A cosine, or sorry, A was R cosine theta, and then B was R sine theta. Okay, and so once you have this, then you're good to go because this number is the same as 2 root 3 CIS pi over 6. And then the second thing you would do, if we're looking for the 4/4 roots, what equation would I set this up as? X to the 4th equals 2 root 3 CIS pi over 6. And then, again, if I plug x equals r CIS theta into here, then this left side becomes what? R to the 4th, CIS 4 theta, and now you're good to go from there. Reviewing. So r to the 4 equals 2 root 3. You can get your radius from there. And then what equation would I use to find theta? 4 theta equals what? Pi over 6 plus, exactly. Nothing, I mean, it's the same process as before, just a few different intricacies as long as you understand what changes. Yes?
Why does R4 equal 2?
Because that's what we got up here for the radius.
Yeah, but you just circled the R4 here.
Yeah, because this is the radius and so is that, so they have to be equal to each other.
And then why did you do 4? Would you get plus 2 pi k?
We always use plus 2 pi k because pi over 6 is just one angle that corresponds to what we need. We can add 2 pi k to get a larger angle that's in the same spot. And that's how we get our different answers. Okay? Well, Brandon, I was going to say, you look very smart with those glasses on, except for the fact that they were on upside down. Goodbye, YouTube.